So the method that I just showed you guys on how to find the inverse matrix by taking the original matrix and the identity matrix that pairs up with it and joining them together and transforming all the elements into ones and zeros, that always works. But if you're dealing with a 2 by 2, so this only works for a 2 by 2, this formula will also work. So I'm going to demonstrate that for you here with example number 3. Okay, so here's my matrix A. So if I want to find the inverse of A, first I have to do 1 over, and I have a number that I need to put down on the bottom down here. This is a scalar number. So normally, like the inverses you saw so far, they didn't have fractions in them, so you didn't notice that there was this scalar. But this part is actually, this is something we're going to be doing later on. It has a name. It's the determinant of the original matrix. All it really is that you are taking the cross products here. So you're taking 5 and 3 and multiplying them together. That would be 15. And you're taking the 2 and the negative 2 and multiplying them together. That would be a negative 4. And you're subtracting those. So the first cross product was 15. The second one was negative 4. You do have to remember that you're subtracting. 15 minus a negative 4 would be 19. That's the fraction part that goes outside the matrix. Again, in some cases, that turns out to be a 1, and so then you distribute it, and you end up with a nice inverse. The other part is just rearranging these elements, basically. So the 5 and the 3, notice A and D right here in the original. Now A and D have switched places. So 5 and 3 in this matrix, they switch places. Notice that C and B are in the same spots, but now instead of being C and B, they are the opposites of those numbers. So the opposite of 2 would be a negative 2. The opposite of negative 2 here would be a positive 2. So be careful. In this case, you might look at it and think, oh, those just switched places. That's not what happened. The C became the opposite of C. The B became the opposite of B. So my inverse is either this, or this is a scalar, if you distribute it, you'd end up with 3 over 19, 2 over 19, negative 2 over 19, and 5 over 19. That would be my inverse. So, how about, for practice, let me give you a matrix. B equals, and then let's make this 7, negative 3, 8, 5. Find the inverse of matrix B. Okay, so hopefully you've tried this. First thing I'm going to do for finding the inverse of B is I want to get that fraction, and then I also want to get the elements on the inside. So if I'm doing the cross product, 7 times 5 is 35, minus 8 times 3 is a negative 24. So that comes out to be a positive 59 for this denominator. Again, the 7 and the 5 go from being where they are to switching places, so the 5 and the 7 go here. And then the 8 and the negative 3, they stay in the same places, but they become the opposite. So this is the inverse of this matrix. If you take these two matrices and multiply them together, you will get the identity matrix for an answer.